discussing about this bitwise operators. So I completed with bitwise AND, OR, and exclusive OR. So today we'll discuss about bitwise operation, right shift operation. Okay. So so all these bitwise operators will come under the category of binary operators. What is a binary operator? So binary operator is the one you have a symbol, that means operator, and if you have two operands, so that is a binary operator. So all these bitwise operators will come under this category, that is binary operators. Okay. See, look at left shift operation. So left shift operation is represented with this symbol, that is less than symbol twice. Okay, so this takes two operands. I'll say X left shift Y. Okay. Normally, when we are doing this, any of these bitwise operators, so both the operators, both the operands, sorry, both the operands, either if it is arithmetic operation, both the operands are considered as integer data, like that is the numbers that is represented in decimal format. Okay, when you come to this bitwise AND or bitwise OR operations, both the operands, so they are converted into binary representation. That means when I write A and B here, so A is converted into binary representation, B is also converted into binary representation, and that AND operation is applied. Whereas in this bitwise left shift and right shift operations, one operand is considered as binary, one operand is considered in decimal format. Okay, here X is considered, X is converted into binary representation. This is converted into binary representation, whereas Y is considered as decimal number. So the first operand in both the operations, in left shift and right shift, the first operand value is converted into binary representation, and second operand value is considered as decimal representation value. Okay, so we'll look at what actually happens with this shift operations. So shift operation means shifting the bits. Shift operation is for shifting the bits. Left to shift, so we'll represent it with the symbol. I'll write like this: X left to shift by Y. That means the value of X that is converted into binary representation, there you'll have some bits. So the values of those bits are shifted towards the left by Y positions. The bits in the X, the bits in the X are shifted towards the left by Y positions. Okay, that is what actually this left shift operation. That means if I have a value like this, five left to shift by one, 5 left by 1. See, what is the binary representation for this 5? What is a binary representation of 5? Hello? 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 Am I audible?
Yes, sir. Yes, sir.
Yes, yes. What is the binary representation of 5?
101.
It is 101, right? It is
101.
101.
Yes.
Yes. So this 5 I'll represent in terms of binary with the help of at least 8 bits. With the help of 8 bits. So look how I'll represent. The actual value is 1, 0, 1. And I'll simply prefix this with zeros. So that means totally I require 8 positions. That means 1 byte. At least 1 byte for representing any number. So some numbers you require more than 1 byte. Okay. So for minimum I require 1 byte. So I'll represent it like this. So I'll append it with I'll prefix it with 5. Okay. So now what I want to do is I want to shift the position of these bits by one position towards their left. In left shift, I'll simply shift the positions of the bit value by left side. In right shift, I'll shift the positions by right side. So you require 8 positions here, right? So what I'll be doing is I'll simply start shifting. That means the first position value is placed in the second position, second position value in third, third in fourth. So like that, I'll simply shift. And what about this? This is simply ignored. Until and unless if it is 1, I'll consider. If it is 0, so I don't mind even if I place a 0. Okay, see, look at the values here. So now this position is with 1, this is with 0. Again, third position 1, 0, 0, 0, 0. Even though you place this 0, it doesn't matter. Okay, but the first position is left empty. But
So
the
why?
first position is left. What?
So why should we leave the first position?
No, no, no. Let me complete. Let me complete. So after shifting, you definitely you shift it by one position. Your left position is left empty. So what it will do is that position is replaced with zeros. That position is replaced with 0. If I shift by if I say 2 positions, the first 2 positions will be empty because the first bit will directly place into third position. So first and second positions are empty. So those 2 positions are filled with zeros. Okay. If you shift by one position, every bit will move towards left by one position. If every bit moves, so there is a vacancy in the first position. So that vacant position is filled with zeros. You can shift the bits by any number of positions, depends on the value of y. If the value of y is 1, I'll shift by one position. If the value of y is 3, I'll shift by 3 positions. if the value of y is 0, I'll not shift any position. Okay. So even though you place this 0 also, it doesn't matter. So because of prefixing with zeros doesn't change the value. If it is 1, definitely the position position will consider. So this is the equivalent binary representation after shifting the positions by leftwards in one position. So now you need to convert this binary value into decimal value. So what is the equivalent decimal value for this? What is the value of 1010? So 2 power 0, 2 power 1, 2 square, 2 cube. So what is the value of 2 cube? What is the value of 2 cube? So again 2 power 1. So you sum up these. So because remaining all are zeros. So then the value of 5, if you apply left shift by 1, it's 10. Hello?
Hello?
You people able to follow or not?
Yes, sir.
Is there any confusion in this?
No, sir.
But not getting good response today. Why?
Sir, the binary of 1010 is 11011110. Sorry.
1010 is
Sorry, wait.
1010 is a binary representation. So convert it into decimal. So this bit will represent 2 and this bit will represent 8. So 8 plus 2, 10. That means 5 left shift by 1. The result is 10. Still you have a problem with this?
No, sir.
Will you take another number? Shall we apply on the same 10 now? So 10 left shift by 1 or 10 left shift by 2, you can do. So we'll take 10 and we'll represent it. So what is the representation for 10 is 1010. So the previous 4 bits I'll append with zeros. So that means I'll get 4 zeros here. And 1010. Okay, so this will go, that means 8th bit will go to the 9th position, 7th bit will come to the 8th position. So like this I'll, right. So here I'll get 1 0 1 0. So these are the actual 8 bits, so which will move towards left by 1 position. So this rightmost position is empty. So if you move towards left side, the rightmost position will become vacant. Vacant positions, I am simply replacing them with zeros. Now the actual value what you need to consider is 1010. So what is the decimal representation for this? So you getting or not getting?
20.
Yes. So this is 2 power 4, 16 plus 2 square, 4. So 16 plus 4 it is. That means if you apply a left shift by 1, so it becomes 20. So got it? Is this clear or not?
Yes, sir.
Why you people saying very doubtfully? So you can even directly tell this without doing all these calculations also. So simple, if it is like say 7, so 7 left shift by 2. So this is simply what you will get is 7 into 2 square. So 2 square means 4. So what is the value of 7 into 4?
28.
So this is what you will get when you apply 7 left shift by 2. So this also you can observe. 5 left shift by 1, that is 5 into 2 power 1. So this 1 is the value of your y. This 1 is the value of your y. If it is 2, 2 square. If it is 1, 2 power 1. If it is shift by 3, it is 2 cube. So here also 10 into 2 power 1.
20.
20. Even though if you convert this 7 into binary, and if you apply this left shift operation, you will get this. So shall we check it, or you people try it?
Yes, sir.
What else? Will you people try it?
Yes, sir.
Yes, you try it. So if you get any doubt, I'll tell you later. Okay.
Okay, sir.
So not now, after the class.
Okay,
Okay,
sir.
this is left shift operation. So left shift operation is simply shifting the bits towards left. By how many positions? By specified the value of y.
Okay.
If you move towards left, your rightmost bits will be vacant. You'll have a vacant positions. So simply fill those vacant positions with zeros. Okay. If you move towards left by 3 positions, on the rightmost you will get 3 empty positions, 3 empty places. So those 3 empty bits will be replaced with zeros. Simply zeros, nothing. After filling with zeros, you convert that whole number into that complete number, you convert it into decimal format. So okay, so this is about left shift operation. So now we'll see right shift. So right shift operation is represented with two greater than symbols. So this is also same like this. X, the number x will be converted into binary. So that binary number values will be moved towards right side by y number of positions. By y number of positions. If y value is 1, they'll be moved towards right by 1 position. If y value is 10, they'll be moved towards right by 10 positions. If it is 0, no change. They'll move by 0 positions. Okay. So when you are making them to move towards right side, now this time you will get a vacant positions on the leftmost side. When you get the vacant positions on the leftmost side, you fill those positions with zeros. Anyway, you move towards left or right, you will get the empty positions on the opposite side. On the other side, you will get the vacant positions. So those vacant positions, you simply replace them with zeros.
Sir.
Hello?
Hello, sir.
Yes, yes, tell me.
Sir, in the left shift, sir, we have a binomial 5 came like 101. So why should we put 00 again, ma'am, sir?
What?
Sir, in a left shift, you have put like 5. Left shift, you
Yes?
have 5 no. So his binary number is 101 na.
Uh,
So after that, why should you put 5 zeros again?
Actually, the value of that is 101. But minimum representation of any number is with 8 bits. That means 1 byte.
Okay, sir.
Minimum representation is 1 byte. You require at least 8 bits to represent any number. If the 8 bits are not sufficient, you can increase to 16. Again, you can increase to 32. Sorry, not 32. 16 plus 8, 24. So that means any number you at least you require 1 byte to represent. Next 2 bytes, 3 bytes. So 3 bytes means 3 into 8.
24.
That's like that you need to increase.
Okay, sir.
But minimum representation is with 8 bits. We'll simply write it as 101. But it is not actually 101. It is with 000000101.
Okay, sir. Thank you.
Okay. So now we'll see a right shift operation. So now convert this 5 to binary. So converting 5 to binary, it is 101. Right. So now make them to move towards right side. So when it is moving towards right side, the first position here is filled with the second bit. That means you are losing this one. I have 8 bits like this. I will lose the first bit. So next I'll get here third bit, fourth bit, fifth, sixth, seventh. I'm sorry, I've written 0 here. It is actually 1. So like this I'll get, that means 8 bits, out of 8 bits I lost 1 bit. So which I shifted towards right. So I'm making every bit 2. That means the actual second bit is filled up in the first position. So actual first bit is, it is simply ignored. It is not considered. So when I am making them to move towards right side, so I'll get a vacant position on the leftmost. So that leftmost value is filled with 0. Now you try to convert this binary value into its decimal equivalent. So what is the decimal equivalent of this?
2.
2.
Yes, it is 2. Okay. So we'll see for this number 10, right shift by 1. So binary representation of 10 is 0, 0, 0, 0, 1, 0, 1, 0. So you have 8 positions like this, 8 bits. So now what I'll do is I'll try to move them towards right side. So that means this is filled here. So like that way I'll get 4 zeros here. So when they are moved towards right side, so there you are getting an empty position. So fill up this empty position with 0. So prefix your number with 0. If you are moving towards right side by 2 positions, you will get 2 vacant positions on the leftmost. So fill them with zeros. So what is the decimal equivalent of 101?
5.
4.
4.
4.
5.
2 bar 0, 2 square. 4 plus 1.
5.
5. So what happens when you say 7? I'll take some number. Not a great, I'm using number. I'll take a 24. Right shift by 2. So what is the value of this one? (24) right shift by 2.
96. 96.
96. How come?
Sir, 24 into 2 square.
24 into 2 square.
Yes, sir.
That is for left shift operation. So what I told previously is for left shift. So see, look at this one. So are you getting the same number 10 into 2 square?
Yes,
Sorry,
sir.
10 into 2 power 1.
Yes, sir.
You getting this one, that one, 10 into 2 power 1. What is the value of 10 into 2 power 1?
5.
Oh, how come you get 10 into 2 power 1 as 5?
Plus 20.
It's 20.
Are you getting that number here when you apply right shift operation?
No, sir.
No. That operation, what I told previously, is for left shift operation. If you apply left shift, it will multiply that number with the 2 power the number you are shifting towards left.
So, sir,
Whereas
what
in
for right?
what?
So, what for right shift?
For right shift, it is 10 divided by 2 power 1. 5 divided by 2 power 1. It is 24 divided by 2 square.
6.
Yes. When you apply right shift by 2 positions, you will get
6.
6. Okay, so this is left shift and right shift operations. So by looking at any number, you can simply say 5 left shift by 3.
Thirty three zero.
It is simply 5 into 2 cube.
40
80.
40.
40, 40.
40. So 2 cube is 8. 8 into 5. 40. Okay. 75 right shift by 4. 75 right shift by 4.
Calculating.
Calculating. 75 divided by 16.
18.75.
18 point.
18.7.
It is coming as decimal.
18 point. Why 18 point? 75 divided by 2 power 4.
2 power 4.
It is not directly with 2. If
4.
you right shift by
4
1, it is 2. If it is your right shift by 2, it is 2 square. If you right shift by 4, it is 2 power 4.
Sir, 4.875.
4.6 something like that.
4.6.
Sir,
You you you
4.875.
you in programming you never say when you are dividing with 2. Hello.
Yes, sir.
In programming, when you are dividing, the numerator and denominator both are integers here. If both are integers, it is, you make it sure the answer is also integer. It is never you say 4 point something. It is 4. That's it.
Okay.
It is just 4. That's it. Here also, when I divide 5 by 2, it is 2.5. But why I say 2? So no decimal part, only the integer part. Decimal part is not considered.
So,
When
sir,
you
only whole part will come.
only,
Whole part will come.
yes, only the integer part will consider. If numerator and denominator both are integers, then you will get only integer value. If it is 5 by 2.0 or 5.0 by 2, if any of them, either numerator or denominator, if any of them is a float value, then you can expect a float answer. That is 4.6, what you are telling now. Okay, here 75, you are dividing it with 16. So both are integers. The answer you get is also an integer for sure. Okay, in programming, it will not consider the decimal part if both are integers. Because if there is any kind of a quiz, multiple choices are there. Yes, you will definitely have one answer with 4, and the very first answer is 4.6. After calculation, you blindly go with that answer, but that is not the correct one. Because we are habituated to write the decimal part. But in programming, make sure it is very clear. When both are integers, your result is also integer for division. Okay. So clear about this?
Yes, sir.
Any doubts in
Yes.
left shift or right shift operations?
No.
So you try for this number, so you verify whether you are getting this logic is correct or not. Okay. You take some random numbers. So first you apply
Give me
this
a question.
what?
Sir, please give me a question to try.
You can take any number, ma. Make it 35, left shift by 3, 36, right shift by 2. You take some number and you try to do it in two ways. So one way is how to convert the binary, apply shift operation, convert it into decimal, and then verify with this procedure, yeah, whether you are in the two cases you are getting the same result or not. Okay, in when you do this one, so it will be easy for you to how to convert to binary, how to convert to decimal. So that will be very easy for you. So you'll get practice for that. So then you'll be easily you can convert. Okay, so when it is uh, any kind of an exam or something, you can just go with this kind of approach, like into 2 power 1 into 2 power 2 square, or like divide by 2 power 1. But in the normal scenario, you make a practice like this, converting to binary, apply shift operation, convert that result into decimal. Okay. So clear with bitwise operators? So next, moving on to the last category of operator, that is some special operators are there. Okay. So that for that special operators we have this comma operator, a normal comma where we use in our regular English. So that is also one operator. That symbol is also considered as one operator in this language. Okay. So the comma linked list expression evaluated from left to right, and the value of the rightmost expression is the value of the combined expression. Like if I write a statement like this, x is equal to 10 comma y equal to 6 comma x plus y. So what is the value of this a whole part is
16.
exactly 16. So this, if the expression is having a comma operation, if there is a comma operation is there, it will start evaluating from the leftmost. So what is the leftmost here? X is equal to 10. So it moves in this direction towards the right. Next, it is assigned with y equal to 6. So already x and y values are assigned. So now it will do this operation, that is x plus y. If the value of x is like this, x equal to 5, y is equal to 10, result is equal to x equal to 1, comma y is equal to 6, comma now what is the value of your result?
What? Why is it
Hello?
16?
What is the value of result?
Six. Six.
It is
Six.
6. Exactly. So previously your x value is 5 and y value is 10. These are the two values actually assigned to your x and y. But later when coming to this expression, the value of x got replaced with 1. That means it will lose this 5 and it got replaced with 1. And the value of y is 10, that got replaced with 6. Now, the third one is x star y. So that it applies on 1 into 6. And that is assigned to result. So, comma, this is having this is the least priority operator we have. I will when in the next topic I will discuss about the priorities and all. So this one is the least priority operator, comma. So when you have a comma operation, it will start evaluating from left side towards its right side. Okay. So this is one operator, that one special operator here, that is a comma operator, and we have one other operator, that is size of operator. So this one we use not frequently, but in some cases we use this operator, which is the size of operator. So size of is one operator which will give you the number of bytes that are occupied in your memory for any data type, for any variable. How many number of bytes got occupied? So that will be given by this operator.
Can you explain again?
Yes, I'll explain. Size of is one operator. So we have different data types like int, float, char, like that. We have data types. So size of is an operator which will tell us how many number of bytes that are actually occupied in the memory per integer. So previously when we are discussing about data types, I told you what every data type will have some amount of memory is occupied. For integer, it occupies 4 bytes. For shorthand, 2 bytes. So like that, for every data type, so there is some fixed amount of memory will be occupied. You remember? Yes, look at this. So for integer, I told it occupies 2 bytes. For shorthand, 2 bytes. For integer, 4 bytes. For long int, 8 bytes. For long int, 16 bytes. Like that way, for every data type, it occupies some memory. So if you don't know how much amount of memory is occupied by that data type, simply you can use this size of operator for knowing how many bytes were actually occupied, because the number of bytes here, it differs according to the type of operating system you are using. So you know or don't know, there are 32-bit operating system, 64-bit operating system, so like that we have. So these are the default sizes I gave for 32-bit operating system. So some computers, some machines will have a 64-bit operating systems. So there the size will get doubles. That means for shorthand itself, it occupies 4 bytes. For integer, it occupies 8 bytes. For long int, it occupies 16. So there will be a difference. So if you are not pretty sure how many number of bytes got occupied by that system, you can use this size of. So size of is one operator which will give us how many number of bytes are actually occupied by that data type. See here, you can look at this example here. Size of int. So this will return the value. How many number of bytes are actually occupied for integer in that particular machine in your system. So where you are executing in that machine, how many bytes got allocated, whether it is allocating 2 bytes or whether it is allocating 4 bytes or 8 bytes. So that byte number will be returned. You can even write like this. If you have an integer variable, if I have an integer variable, say a, so I can even apply the size of operation on a. Size of a. So a is nothing but integer. Okay. If you have double d, I can write size of, or I can write size of double. So this both will give me how many number of bytes actually occupied by a double data. Okay. If you are not sure, you can use this. If you are sure, you can directly use, okay, integer occupies 4 bytes. If you are sure about that, you can use it. If you are not sure, you can use this operator for finding out how many bytes got occupied by integer for any data type. You can write it int, you can write float, you can write double, you can write long double, you can write character, for any type of data. Okay, so that is about size of operator. So I hope I'm clear with this. I'm done. If you have any doubts, you can ask.
Sir,
Yes.
in where should we use the size of operator?
If you want to know how many bytes that got occupied by integer, or how many bytes that got occupied by float, so then you can use a size of operator.
Okay, sir.
So any other doubts?
Sir, I have 64 operating bit system.
Okay. So generally the sizes of a 64 operating system, 64-bit operating system, are actually double the bytes that what I told in that table.
Okay, sir.
So you will not use them now, but later in some concept we need to come across, when we are allocating the memory. So there we have to find out how many bytes got actually occupied. So depending on that size, I'll allocate the memory. So there will come across usage of this size of operation.
Okay, sir.
So okay, you have any other doubts?
No, sir.
Sir,
Yes.
sir, I have not received your recorded classes. Can you send?
So sir is sharing in that group.
I didn't receive.
I will check with the sir. You are there in that group, right? But actually, no. Sir is not sharing every day. They are actually placed in the drive. So the first day, sir has shared one Google Drive link. So there you
Only,
can access all the videos.
only I can have only one video, sir.
No, I'll check. We'll check with the sir once. The Rajesh sir, I'll ask him. So I'll ask him to share that link once again. So there he's uploading all the videos there, so you can access directly from there. So no, every day he's not sharing the link separately.
Okay, sir. Thank you.
So any other doubts?
No, sir.
So we can leave then.
Okay, thank you, sir.
Thank you. Sir, Rajesh sir.
Sir, completed, no?
What?
Completed, no, sir?
Yes, yes.